Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Welcome back to another problem of the day discussion. So today we'll be discussing yesterday's problem of the day, that is nothing but next happy number. So we'll first of all understand what is a happy number and how to find it, and then after that we'll see how we can solve this problem. So guys, please give me a +1 in the chat if everything is working fine, and you can hit the like button as well. Then I'll share my screen to discuss the problem further. Hi Rishit, and hi to other people as well. So I'm sharing my screen, guys. Let me know once it is visible. Okay, yeah. So I hope that now my screen is clearly visible to everyone. So what I will do is, first of all, I'll tell you about the definition of the happy number. Right? What is a happy number? So basically, suppose a particular number n has been given to you. Right? So you have to tell whether it is a happy number or not. So what is the definition of n being a happy number? Hi Gopal, Chandra as well. So basically, what we can understand is that a number is called happy number if it leads to 1 after a sequence of steps, wherein at each step the number is replaced by the sum of the squares of its digit. So suppose that we have been given n is equal to 8. Okay, suppose that we have been given the number. Okay, and we have been given the number n is equal to 8 here. So suppose n was given as 8. So what we will do is we will have that number, we'll get the number, and we'll take the sum of the squares of the digit. Okay, so basically what will be the sum of the squares of the digit? So basically it will be nothing but 8 square here, which is going to be 16, right? So we'll store the new number as sorry, 8 square is going to be 64, right? So then what we'll do is we'll get the new number as this 64. Okay, after this we will again take the sum of the squares of the digits. So 6 square plus 4 square is what we are going to have. Now the new updated n value will be nothing but what? It will be 100, right? Now after this again we will take the sum of the squares. So 1 square plus 0 square. Okay, plus 0 square is what we are going to do. So we will get the n value as 1. Okay, so ultimately whenever we get a particular n value in the starting, okay, so after this what we will do is we'll take the sum of the squares of the digits, and then we will get a new number, and then for that number also we will take the sum of the squares of the digit, and we will keep on doing it until and unless it is more than one digit. Okay, and then at the end when the n becomes one digit number, right? So when the n will become a single digit number, and if n value becomes 1, then I will say that it is a happy number, right? Is this part clear to everyone, guys? Yes or no? In this case, if I'll just show you, so just a second, you can see if we start with a happy number, sorry, if we start with a happy number and keep on replacing the sum of it, then we can reach 1 at the some point. So is this part clear to everyone, guys? Please let me know. Like suppose that you start with 8, then basically only one digit is there, so you take the square of that digit and that will be 64. Then this is the sum that you get, 64 only. Then for 64 you take the squares, so 6 square. Can you explain 64 step again? Okay, so when you will get, whenever you will have a particular number na, so as you can see Rishit, we had 8, so only this particular 8 was there as a digit. So we take 8 square, we take the square of the digit. Okay, so basically 8 square is only there, so we get 64. So we get this as the sum. Then we will say that okay, now we will consider 64 as the number, and then we are going to repeat the same process. Okay, we are going to repeat the same process, that we will take the digits and we'll take the square of them, and we'll add the sum. So 6 square plus 4 square, so this will be 30, sorry, 6 square, when I will do 6 square plus 4 square, no, just a second, I have made a mistake, very sorry. So when I will do 6 square plus 8 square, no, so it will become 36 plus 16 here, right? Very sorry Rishit, thanks a lot for correcting me. So here what will happen now, in this case this value will be nothing but this will be 2 and this will be 5 here, if I am not wrong, correct? Yeah. After this, what will happen? Well, the new n value will be 52, and we'll take the squares. So this will be 25, and plus we'll get 4 here. And then after this, if you will keep on seeing this, so just a second. Yeah, 8 is a happy number since is 10. After happy number after 8 is 10. Yeah, that is fine. So yeah, you can clearly see here when I will have this now. So yeah, I'll get 29 here. So then after 29 you can see that when I'll take when I'll say n is equal to 29, so now again I'll take the squares, so this will be 4 plus 81, right? Then n value will get updated to what, 85 I think. Then after that n value will be what, 64 plus 25, So n value will become nothing but here you will have 9, you will have 8. Okay, then again you take the squares, right? So you will get what, 64 plus 81. So that will become nothing but 5 and 1 2. So this will be the n value. Then this will be what, 25 plus 1 plus 4. So this is going to be, n is going to become 30. And then what is going to happen, n is equal to, this is going to be 9 plus 0, right? Then n value will become what, it will become 81 plus 0. Then after that n value will become what, 64, sorry, yeah, 64 plus 1. So it will be 65 when you will keep on repeating the process. Now basically they are saying that n is equal to 8 is a happy number. So what is the next happy number, right? So in this case, when you will see n is equal to 10 here now, so what will happen when n is equal to 10 is given? So basically when n is equal to 10, you take 1 square plus 0 square, so you will get basically 1 here. So you can clearly see that now this is a happy number, because the moment the sum of the squares of the digit become 1, that is when you should stop. Are you getting my point, guys? Yes or no? Please tell me. You have to find the next happy number. So a number is a happy number whenever, so you will be given a value of n, and you have to find the next happy number. Okay, so basically suppose if you talk about 13, so why is 13 the like, when suppose that n was given as 10, so when n was given as 10, so 13 is the next happy number. Now how to check if 13 is the happy number or not? So suppose that if you are having 13 now, okay, so you can see for 13 you will have 1 square plus 3 square. So this will be what, 1 plus 9. So this will be updated to 10, right? So when you will take the squares of the digits, so this will be 1 square plus 0 square. So this will be 1. So you can see that after repeating the process again and again, if you take the sum of the squares of the digit, so you can see when you have 13, so you get the sum of the squares as 10. Okay, so still it is a 2-digit number. So you again take the sum of the squares of the digit, and then you get this single digit number. You might get a multiple digit number also. Then in that case you will keep on adding the sum of the squares. But whenever you get the single digit number, so when you get n is equal to 1, that is when you can say that it is a happy number. Is this part clear to everyone, guys? Please let me know, yes or no. Is this clear? That we will keep on doing it. Okay, so we will check it for 11, right? 11 will not be a happy number. We'll check it for 12. So 12 will not be a happy number, right? Then we'll check it for 13, and for 13 it will be a happy number here. Is this much part clear or not, at least? Guys, please tell me. Is this much part clear to all of you? Everyone, if you're clear, please hit the like button and tell me in the chat whether you're clear or not. Are you all clear with this much part, guys? Basically you will be given a n value. Okay, here what you will be given is, you will be given a particular n value, and what you need to do is, suppose n is equal to 10 is given, so you have to find the next happy number after n. So n is given as 10, so you have to, if n is given as 10 now, so if n is given as 10, so you will check whether 11 is a happy number or not. So you will be able to observe that 11 is not a happy number. Then after that you will check whether 12 is a happy number or not. So when you will run this, so 12 will also not be a happy number. Then when you will check for 13, so 13 will be a happy number, because if you will see, 13 is what, 1 square plus 3 square. So it is going to become nothing but what, 1 plus 9. So it is going to become nothing but 10 here, right? So then you will have the number as 10. So for 10 you will do 1 square plus 0 square. So there you are going to get what, 1 plus 0. So that is nothing but 1. So at the end, when you get a single digit number, and that is 1, that is when you can say that it is a happy number. Is this much part clear to all of you, guys? Is this much part clear to all of you, guys? Please let me know. I think the internet connection is fine now. Yeah. So can you all see me now, guys? Yeah. So no. Okay. So is this much part clear to all of you guys? Right. How to check? So basically, what I'm saying is that whenever you will be given an n value now, then what you need to do is, you need to do n is equal to n plus one. Okay. So we need to move to the next. We need to move to the next number, and we don't know until where we need to move. So what we will do is, we will simply do what? We will simply have a function, solve function, which is going to check whether the current number n is a happy number or not. If it is a happy number, then this function is going to return true, and if it returns a true, then we will return n, because that will be a happy number. Otherwise, what we can say is, otherwise we will do nothing but n is equal to n plus 1. Otherwise we'll keep on updating our n, and if we don't get anything, then we can return 0. Is this much part clear to all of you guys? Yes or no, please tell me. right? So basically what I'm saying is, whenever you'll be given the n now, so you have to check after n, like after n is given as 10, so you'll check whether 11 is a happy number, no. So whether 12 is a happy number, no. So you will keep on increasing the numbers, and then you will check for 13 also. So for 13 you will be able to find out that the function will return true because it will be a happy number. So then you can directly return 13. That is what we need to do. How you are checking 11 and 12 are not happy number? So basically when you are checking for 11 na, so suppose if you have 11, so when you have 11, right, so you will take the squares of the digits. So 1 square plus 1 square is what you will have, so you will get nothing but 2. Okay, after 2 what will happen, you will take the squares again, so this will be 2 square, that is 4. Then after that so basically when you will be up and running for it now, so you can see that what will happen here is, when you had 11, so you did the squares, then you'll get nothing but 2, so you get a single digit number. But is it equal to 1? No, it is not equal to 1. So that is why 11 is not a happy number. Similarly, if you check it for 12, so 12, for 12 what happens, it is 1 square plus 2 square. So basically this will be what, 1 plus you can say what, 1 plus 4, I think, right? So 1 plus 4, after 1 plus 4, what you are going to get is, you are going to get 5 here. So this is a single digit, right? This is single digit. But it is not, but not 1, but not 1. So this is also not a happy number. Now, are you getting the point, everyone? Especially Vaibhav and the other person. We stop checking the process. Yeah, we stop whenever the number becomes a single digit number. That is when we stop. So is this part clear? Also one more thing, suppose that the n value is 7 also na, then also it will be a happy number. Why? Because if you will do 7 square, so it will become 49. Then for 49, if you will do the square, so it will be 4 square plus 9 square, right? So it is going to be nothing but what, 16 plus nothing but 81. So this is going to be what, 7, and this is going to be 9. So after this is going to become 81 plus 49 after this. So this will be 0 and then 1 carry, so 130 is what you're going to get. Okay, and then you will observe that 1 square plus 3 square plus 0 square is going to give you what? It is going to give you 1 plus 9 plus 0, that is nothing but 10. And when you get 10, so 1 square plus 0 square is going to give you 1. So when the n value is 7 also na, then also it will be a happy number, right? When the n value is 1, then also it will be a happy number, right? And also you can say that when n value is 7 also now, then also you see, when it is 7, then you can keep on repeating the process. Yeah, like when it is 7, then you should not give up, because when it is 7 also now, then if it is 7, then you should not say that it is not a happy number. Because for 7, if you do 4 if you'll get 49, then for 49 you do 4 square plus 9 square, so you'll get 16 plus 81, that will be 97. After that you will do 9 square plus 7 square, so that will be 130. And then for 130, if you take the square, so 1 square plus 3 square plus 0 square, so you'll get 10. Then for 10 you will do 1 square plus 0 square, so you'll get 1 here. So for n is equal to 7, you can say it is a happy number. So when it becomes a single digit number, right? When it becomes a single digit, and when the n value becomes equal to 1, or the n value becomes equal to 7, then it will be a happy number. Please write yes in the chat. Is it clear? Please write 17 in the chat. Okay, so then it will become happy. Is that clear, guys? Please let me know. Is this part clear to all of you or not? Okay, that when n is 1 and n is 7 also, right? If n is 7 also, then also it will be a happy number, because ultimately when you'll keep on repeating the process for 7 also now, then it will ultimately reach 1 only. Right, guys, please write 17 in the chat if you're clear with this, right? So 1 is also a happy number, right? 1 is, n is equal to 1 is also going to be a happy number. And if n is 7 also now, then also it can be considered as a happy number. Both the states can be considered as a happy number, because n is equal to 1 directly shows a happy number. When you have 7 now, then if you'll keep on repeating this process, so you'll get 49, then you will get what? For 49 you will get 97, then for 97 you'll get 130, then for 130 you'll get 10, then for 10 you will get 1 as a sum. So ultimately n is equal to 7 is also going to give you a state of 1 ultimately at the end. So when n is 1 or when n is 7, so in both the states you can say that it is going to be a happy number. Otherwise if it is a single digit number other than 1 or 7, so it is not going to be a happy number, right? So can I say one thing, that what are we doing here, right? So if I will think about the solve function, right? If I'll think about the solve function, and in that case I will pass the n value here, no? So what are we trying to achieve here? So you can clearly see that if it happens, right, that n value is equal to, like, see, if n is a single digit number, right? So suppose that if it happens that n value is less than equal to 9, okay, And if this happens, right, that the n value is equal to 1, or the n value is equal to 7, then I can say that I will return what, guys? I will return true, because it is going to be a happy number. Otherwise, if it is a single number other than 1 or 7, then I'm going to return false, because it will not be a happy number. Is this part clear to everyone or not, guys? Please tell me. Right? Is this much part clear to everybody? Right? Otherwise, what are we going to do? Can I say that we are always repeating a particular process? You can see that what we are trying to do is, we are always trying to find the sum of the digits, right? Sum of the square of the digit, and sum of the square of the digit, right? And whenever you find the sum of the square of the digit, so then after that you are checking that whether that particular sum of the, like, then you are calling the function again, that whether 97 is a happy number or not, right? So for 97 you are again calling, so you are repeating the same process again and again. So what we need to do here is, now after the base cases are covered, then we will simply write that we need to declare our sum variable as 0, guys. Okay, and then we will find the sum of the squares of the digit. So we will say that while the number is greater than 0, till that point of time we'll find the digit. So digit will be number modulo 10, and the sum will be what? Sum is equal to nothing but sum plus digit into digit. Okay, and then we'll make the number is equal to number divided by 10, so number will get updated. And after this part has been done, then in that case again we will call the solve function for this updated n. So basically we can say that now that updated n value will be nothing but the sum that we have got, right? And then we will say that let's return the solve function for this updated n. Are you getting the point? So we'll check for it whether it is a happy number or not, and based on that we'll return. So we have to repeat the process again and again. So that is why this is nothing but recursion process here. Is this clear to everyone, guys? Please let me know. Are you clear with the ideology or not? Are you getting the point, guys? Yes or no? Please tell me. I'll just show you here. Right. So what we are doing here is, again, as I already told, that if n value is 1 or if n value is 7, then we return a true. Otherwise, if it is any other single number other than 1 or 7, then I'll return false, and I'll find the sum of the digits. Okay. So while the number is greater than 0, so we'll find the digit, we'll take the sum. So digit into digit will take, and then we'll update the number as n by 10. And then again, we'll call the solve function for that particular sum, guys. Okay. Why we are calling the solve function again? Because you can see now, again and again we are repeating the process. Because when we got the n value as, suppose we got the suppose we had got any particular n value, suppose we got the n value as 13 here, right? So we found the sum, right? So when we got the n value as 13, then the sum came out to be what? The sum was nothing but 1 square plus 3 square. This was nothing but what? 1 plus 9. So the sum came out to be nothing but 10 here, right? So in this particular case, again for this particular sum, so we can say that now n will become 10, and for this guy we are going to call again, we are going to repeat the process. So when we are going to repeat a particular process, so since solve function is repeating this process, so I'll for this particular number, so we can say that the new updated number will be nothing but the sum, if you want to write it like this, and then we can call it for the n here. Are you getting my point, guys? Everyone, please tell me. The time and the space complexity, Ricky is asking. So just give me a minute and I'll explain. But is it clear to everyone, guys? So since we are repeating the same process again and again, na, for the new n value, that is whatever sum will get, that will behave as the new n, and we should call the function again, because we have to repeat the process again and again, and we have to check whether, if it is a single digit, then in that case we'll be very happy to check. If it is 1 or 7, then we'll return true, otherwise we'll return false. And what you need to observe right here is that otherwise we'll find the sum of the digits, and then we'll call the function again we'll call. So basically you can very easily see here that what we are doing here is, now we are just simply running the while loop here. And when you run the while loop now, so whenever you are dividing by 10, so in the while loop you are doing n is equal to n divided by 10. So this basically means that the time complexity will be log n to the base 10, right, for the solve function. And since you might be running for n different values at the worst case, right, so you might be running n plus 1, n plus 1, n plus 1, so that is why overall complexity will be n log of log n in the worst case. So is this part clear to everyone, guys? Because you can see we will find the next happy number very closer. So that is why you don't have to do much iterations. So the solve function is going to take log of n to the base 10 time, right? Because this is the time that it will take, because you are just taking the sum of the squares of the digit. So it will not take much time, and since you are iterating at most n times because you are running this while loop now here, so in the worst case you might be iterating n times or something like this, so that is why it will be n log of log n. Is it clear to everyone, guys? Please tell me, is there any part here that is not clear to all of you? Anyone is not clear with any of the parts here, or is this question clear? Rishit, please tell me, and Gopal also, you can tell me, and other people also, they can tell me if it is clear to all of you or not, guys. Is this question clear to all of you? I'll just quickly do one thing. I'll just quickly try to run this code as well, and then we will try to see. But the recursive call will add to the time complexity. Actually, what you are saying, I will tell you what you are saying. For that, I will tell you, Rishit. What is happening here is now. See, you have a number, right? So for that, you will take the if you talk about the solve function now. If you will talk about the solve function, so first time, how much time complexity is going to take? First time it is going to take log of n to the base 10 complexity, okay, to the base 10, this much complexity. Then after that, the updated new number will be there, but the calls will be constant. Like if you are calling it k number of times now, so k will be fixed because you will be able to observe that very easily you will get the single number, okay. So it will be called, let's suppose that you are calling the recursive function k number of times, okay, but k will be a very smaller value, okay. K will be a very smaller value because suppose that if I had 13 here, right? So you can see that for 13 we got the sum as what? We got the sum as nothing but 1 square plus 9 square. That was nothing but sorry, 1 square plus 3 square, right? So we got the sum as 1 square plus 3 square, that was nothing but 10 here, right? So then the n value got updated to 10, okay. Then we got 1 square plus 0 square, then we got what? 1 plus 0. So that was nothing but 1 here ultimately, right? So this is what we got as the sum, and that is the final number. So the you are saying the correct thing that we are repeating this thing again and again, but for one time it is going to take log n to the base 10 time. I agree. And you are saying that it might be called k number of times, but k will be very small. So that is why it will not be taken into consideration, because very at after some iterations now, you will be able to get a single digit. Is that fine? Because the base condition is that you need to get a single digit. So after some iterations you will be very easily able to find the single digit number. Are you getting my point, Rishit, or not? If you will try to run it now, if you will try to run it for even bigger cases, so you will be able to observe that after a certain point of time it will always keep on reducing to a single digit, so it will not take very much time. Okay, that is why I'm saying that it will be log of n to the base 10 for checking the happy number part. Okay, I hope that this question is clear till now to everyone. I'll just, and it was not a hard question, I would say. So just a second, I'll update the code link in the chat, and you can tell me whether everyone is clear or not. Okay, guys. So I am just pasting this link, just a second, and yeah, let me run this. Is there any doubt that anyone is having, or everything is clear, guys? Please let me know. So yeah, we have this link. I'm sharing it in the chat. All right. So yeah. Okay. So Rishit is saying that he is clear with this question, and Ricky is also saying that he's also clear. So is there anything that you are not clear with, guys, or anything that you want to ask with regards to this problem? Because it was a quite easy problem, I would say. But yes, happy number is asked often, sometimes in the interviews also. So you can be prepared about it. Okay, so thanks a lot everyone for joining for today's session. And this problem was not that hard. It was a bit medium level problem or easy level problem only. So I'll see you with another problem of the day in the next week. Till then, keep coding, guys. And thanks a lot for joining. If you are watching the recorded session, so please hit the like button and give a right understood in the chat if you have understood. Thank you, and keep coding, guys.